The question we're tackling here today is a little bit wordy. We want to use continuity and properties of limits. We're going to be looking at this particular function right here, x plus square root of x minus 4, and we are looking at the interval from 4 to infinity. Notice it's closed on the number 4, which means it includes the number 4. We want to show that that function is continuous on that interval. So let's actually start into this. First thing, we have to go through and remind ourselves what it means to be continuous. If you are continuous on an interval, it means you are continuous at every number in that interval. Okay, so that sounds still a little bit complicated. That means, okay, let's say we have an interval from A to B. You're going to take all the numbers in that interval. Let's take little c, and we want to show that the limit as x goes to c of f of x is the same thing as if we just plug that number in. So that's going to give us f of c. So basically all we're going to do is we're going to take a limit here of everything, and we're just going to show that we get exactly what we'd get if we punch that number in. So working with the problem that we have here, we're going to take the limit as x goes to, and I'm just going to call it a, of our function, and our function is x plus square root of x minus 4. And we're going to use the properties of limits to show that this is going to be equal to f of a. And in this particular case, I'm going to take a to be in the interval from 4 to infinity. Now, you'll notice here I actually used an open interval here. I didn't include the number 4. We're going to see why in a little bit. We have to take that case and look at it separately. All right, if you feel comfortable just punching in a and saying, okay, any number in here is going to work, that's fine. That's actually what I would go for. So notice between 4 and infinity, there's not going to be any issues, right? We are going to have the number under the square root. A minus 4 is going to be bigger than 0 because a is bigger than 4, even if it's just infinitesimally bigger. Even if it's just a little bit bigger, right? 4.1, 4.0001. Either way, that number is going to be positive, which means we can take a square root of it and we're going to be perfectly fine. And that is going to be the same thing as f of a. So that's not going to be an issue when we take numbers that are bigger than 4. So here's our caveat. At 4, we only need the right-hand limit. And that is going to be what actually saves us in the end here, x minus 4. So when we talk about the right-hand limit, you'll notice that what I put in here was a plus sign where we normally see an exponent. That means we're coming in from the right-hand side. In other words, it's numbers that are slightly bigger than 4, which means, again, right, it's going to be something slightly bigger than 4, so our outcome is going to be positive. And when it reaches 4 itself, notice what we're going to get is 0, and square root of 0 is 0, so we're going to be fine as we go through that. So that is going to give us the same thing as 4, let me go back to black, is equal to 4 plus square root of 4 minus 4, which is equal to 4. So, and I'll put a equal then. So we actually have, everything is okay there. We have an issue if we had to go below 4. And the problem for that, and this is just kind of as an aside, is if we took the limit as x goes to 4 from the left-hand side, x plus x minus 4 square root. Notice if we take any number like 3.9 minus 4, any number that's slightly less than 4, we're going to get a negative number, which means that this element here x minus 4 is a complex number. And normally, in most calculus classes, we don't involve ourselves with complex numbers for the most part. And so we only want to work with real numbers when we're looking at limits. So this is not going to be something that we're going to work with at all. So you got to remember when you're going through this, break it up into two parts. We got our first part here for all a that are in 4 to infinity, and then we have our second part where x goes to 4 only from the right-hand side. Thanks for listening.